Okay, it's my big pleasure to welcome you all for today's seminar. I may not need to introduce our speaker today because I guess most of you, if not all of you, have worked with them at some point during your careers. Jim Moore has been working here, 35 years, a little bit more than 35 years?
Seems like an eternity.
An eternity. In fact, I talked with him earlier. He got his degrees from Florida State and from CU last millennium. So that's a little bit long, but he said that, not me. Before joining NCAR, Jim actually worked 12 years at the Bureau of Reclamation, and then came here to NCAR at the time. I don't know, was it ATD probably, or Field Observing Facility. But yeah, Jim is a veteran project manager who has managed some of the most significant atmospheric science field projects of the recent decades to better understand the weather and climate. And I'm looking forward to his talk, a 35-year journey supporting geosciences, research field projects, perceptions, lessons learned, and the remarkable future. Please, Jim.
Thanks. Thank you. Thanks, everyone. Thanks for coming out to this. I think hopefully we've got a few other people that have joined via the miracle of modern technology. So people are still straggling in as usual. Hi, Jim. So let's see, a little bit of history about me to start with. So this is I call it the Jam Calendar, James Alfred Moore, the Jam Calendar, 20th and 21st century. So you can see we start over here. I was born in 1950, and here we are down here today. And what you see on here is just a sampling of the some 80 projects that I supported through my tenure here at NCAR. So you can see the little Jim with quite a bit more hair than I have today, even as a little guy. And down here we are today, as was mentioned, colleges at FSU, at the University of Nevada, and at CU, and then the field projects for me. Starting first one here at NCAR was the Olympics, which is the 1984 Olympics in Los Angeles, and I just put a sampling of the others in here, and we'll come back to some observations about all those as we go on. Some things a lot of things have happened technologically in my 68 years here, and starting way back with the telephone modem in 1956, the first weather satellite, Tyros 1, in 1960. And on we go. The internet pops up there in the early 70s. Now the dates of these, I went online and searched, and there is some discussion about the dates, which one's which, but these are the ones I'm sticking to, these dates. The PC came about in 1981. I got my first one in 1985, I think. Motorola, which was the first cell phone, the big brick cell phone you might recall from the past. The World Wide Web pops up in 1989. You can see various languages, HGTV, the Wi-Fi shows up. Facebook, Twitter come into being here in 2004, 2005. And so what's happened here is that astounding communications revolution for all of us. And that has really impacted the way we do business and do field projects, among other things. So, what's a field project? There are all kinds. There's single, small ones. There's short duration ones. There's education ones. There's, small and large as defined by the National Science Foundation. There are rapid response ones. There's long-term sampling efforts that go on. Local, regional, and national projects. They're big international collaborations. This is what's been so rewarding and fascinating for me, is that all these different ones require all different types of capabilities. The scientists that come into play here, and then what we do to support them to make these all turn out to be a success. And I'm happy to say I was part of some of those successes, hopefully many of those successes. So the phrases that I've grown to love and hate through 35 years. You want to do what? Where? I'm sorry, we can't get there from here, I can't make this stuff up, and boy, I'll tell you, that one is one that has been around a while. And then there's the here it comes, which is the weather chasing you rather than you chasing the weather. Mother Nature will be feisty today. We missed it by that much, we almost got the perfect case, but we never got the perfect case, right? So we got to keep after it. Then for me, I always need to try to find a magnum bar. So it turns out that I have found these on 4 continents. I have found magnum bars. So it's something I always look to. There's always a comfort. It's like having a glass of warm milk. It's just a comfort thing to be able to do that. I don't have an opinion, and neither do you, Morris. So, and so, another one, a great one. This should be easy, And then finally, it's a field project, not a vacation. So we have all been accused, all of us in the room that participated in these things, by others that we work with and our family. You're just on this, you're just taking a vacation here, and oh my, are they so far from the truth. Here's the thing. These are very complex. What I've shown here is just an example of a large project. The important thing here is that the process of planning these can start 3 years and sometimes more than that, 3 years ahead of a very modest field phase that might take 45 days. We might be able to get aircraft and radar and ships and ground facilities and all this for 45 days. We plan for 3 years. Then we spend the next 10 in the case of some of the projects that I showed on the timeline, 20 years analyzing the data that come from these. And so these have they're a life cycle, and they have a life cycle of their own as well. And we, as you might know, sometimes we have several of these projects going on at the same time or very near one another. And so there's a lot of activities that have to be planned for in advance. One of the big components of these projects, and it's become more and more important, is the whole data management component of this. There's a planning that goes on now related to data management, and then after the fact, how do you make the data available to the science community for the analysis that we all want to do with the information? And it's so very important that all of the facets of this, from the operations to data management to the science objectives, all these are carried through. The thing that I'm very proud of, at least for myself, have been able to help the scientists keep all these different phases going. And also I've learned so much. I think all these different projects that we've had, the opportunity to be with the best and the brightest doing these things and learning from them is just experience that I can't describe. Small is good. There have been a number of projects that have a single, in this case, a surface flux facility, ISF. This was out on the eastern plains of Colorado just a few years ago. A C-band radar in Taiwan. And then, of course, we scale up from there. What I show here is the HIPPO project. This was the hyper pole-to-pole study. This one was, I believe, one of the first times that we actually tried to do a full sampling of our atmosphere, chemistry, and atmospheric components as well, across latitudes from 80 north to almost 70 south, and that could not have been done 20 years ago. And it's not for the aviation part so much as the rest of the communications and all the other things that had to come to bear, the logistics and all the rest of it that was brought to bear on this. Of course, having our Gulf Stream 5 allowed that to be done, and the chemists for the first time to be able to see the whole Earth in its cycle of chemistry and atmospheric sciences. It was amazing. One that I worked very hard on was a project called Dynamo, which was the dynamics of the Madden-Julian oscillation. Now, this project occurred in various places, but centered in the Maldives, in the Indian Ocean. Diego Garcia nearby, and also in the oceans nearby as well. The Japanese were involved. This is a classic situation of a very complex international many scientists from around the globe, from different institutions involved in this, with a host of platforms of all different kinds here. Everything from oceanographic sensors to airborne and ground-based sensors to aircraft. 3 ships were involved, and a variety of other sensors from the ground, as well as a radar complex in the Maldives that, to my knowledge, really hasn't been duplicated in terms of the different frequencies and the capabilities that the folks were able to do. Getting this all set up and getting this put together was indeed a challenge. So what do we learn from what have I learned, at least, from all these different projects and the samples that I've shown you? The first thing, obviously, developing the good science goals and achievable goals. So the good science goals, the scientists are constantly coming up with new theories and ideas about it. Then there's this matter of the theory and reality, and we'll come back to that a little bit. The theory is one thing. The reality of doing it practically, making the measurements and all, is when someone like myself and others in the Earth Observing Laboratory come in and help them do those kinds of things. Next, let's see. Next is the science teams. But you want to make sure that the objectives in these projects are from the different scientists are complementary. Some of the biggest battles that I've seen is trying to figure out, who gets the aircraft today, or who gets the aircraft tomorrow, or the ship, or whatever. Who's going to run the radar? What scanning strategy will we use for the radar for the next 3 hours? And these things are things, they sound trivial, but I'm here to tell you there have been some serious, sorry, there's something that keeps popping up here that I have to, UCAR is watching me, making sure I'm not doing anything untoward. The sampling strategy also, this is again where the rubber hits the road. It's quite one thing to say, these are the observations I'd like to make. It's quite another to say, well, the aircraft and the radar and other things can make these kinds of observations. And this one, again, is where the Earth Observing Laboratory expertise and other experience that we have come to bear on what's going on. Good planning and lead times. One of the biggest challenges we have, it's in order to put one of these projects together and conduct it in another, especially in another country, even in the U.S. sometimes, but certainly in other nations, this requires a lot of planning. And sometimes the planning that's required, the length of time in advance, is at odds with when funding decisions are made. And being able to help the funding agencies understand why we need to make decisions and move ahead with something and why we need some answers far ahead of time in order for us to pull it off. This is one thing that I spent a lot of time doing for the various projects I supported. And it's hard. This isn't easy to do. And it's something that I hope we learn from each time. We gain more experience. Participant expectations. The scientists have high expectations. The things, because of all that technology that I showed early on and for a lot of other reasons, we can do a lot more now than we were able to do even 10 years ago. We want to make sure that with those capabilities there comes a reality check in terms of what we'll be able to do wherever we're parked to try to make our measurements. The real-time coordination and observational strategies also requires planning, and at least in my case, the experience that I had with projects through the years allowed me to help the PI sometimes figure out how best to proceed to make these things move on. And it's to get the answers to the science questions they had. This is a really important part. We have to manage those. We have to manage these things, these expectations, to make sure that we're not overselling our product and our capabilities, but making sure they get the information they need. And as I said before, of course, the final legacy are the data and publications. So the Earth Observing Lab, we have a data management support group that that provides the very core of that support to the community that we provide support to. And this is something, of course, the NSF requires these data to be made public and made available to the science community. And it's becoming, with what's happening, one of the biggest things that's changed here is that people want to see this information in real time. So we developed this thing you may have heard of called the EOL Field Catalog that allows you to look at real-time measurements as well as other products that might be available to help the decision-making process as we move along. You got to have a good logo and an acronym. It's simply, I mean, I'm sorry, the rest of it really, yeah, sure, the science is important, but if you don't have a logo, you're toast. It's all right. So the science team, this speaks for itself. I really have nothing to add. The personality of the project. It really, each of these projects have their own personality, driven in large part by the ducks on the bus, on the bike here, and how the ladies and gentlemen come together and how they work together is really a main driver in the success of the project. One of the things that, as a project manager, to help these along, one of the most challenging parts of this is to try to keep everybody happy, and making sure that they get the answers that they want without, taking one another's lives in the process, So it's a valuable thing. So what other lessons have I learned in doing this? Well, it seems for some reason there's an interesting time thing that goes on there. It takes a week to set up an operations center, but really in 4 hours you can tear it down. For the first 10 years or so, it took a long time for us to get this figured out, because we'd make travel plans and we'd be sitting twiddling our thumbs while we're trying to, after the project is over, we all want to go home, but we assume it's going to take about the same time. Not so much. Related to the point made at the end of the other side, we're running out of acronyms too. I mean, we have a huge recycling program underway, and but still it gets very confusing when you use as many acronyms as I have. Invariably, I'm getting anything with a C in it. I constantly foul up. Be careful what you wish for. It can come true right in front of you, as some of you in the room have seen when tornadoes chase us down, or bow echoes chase us down, or whatever. In my case, hurricanes, and actually only just in the last 6 weeks a hurricane chased me down. I retire. I thought Mother Nature, I thought she was done with me. I said I retired. Well, here comes Florence right at me. Anyway, you got to be careful what you wish for. Scientists and PIs can be like children behaving badly. What can I say? I'd like to. My spouse cautioned me not to put this in, but I said, these are most of them are big boys and girls. They can understand this for what I'm trying to say. How many times have I said, "Are you kidding me?" Well, a lot. Be mindful of where you choose to build your op center. So what can happen is you want to, you typically want to have the op center near the center of the action. The trouble is the action can really tear down your operations center if you're not careful. So you just have to be careful about all these and this is all part of this planning that goes in weeks and months ahead, site surveys and other things that go on to help help us all understand what we're getting ourselves into with the particular projects. More than 2 planning more than 2 planning meetings a day are counterproductive and can be actually destructive if you're not very careful. So this comes with experience. There's a T-shirt from a project that I participated in called Stormfest, which is a wintertime project, and on the back of the T-shirt it actually listed the meetings. There were 8 meetings a day that would occur, and I almost had to bring in the local police to deal with the problems that ensued from this. People need to be separated at times. No do-overs. You just keep moving on. Try to get it the next time. Yeah. So one things you don't think about, I'm forced to think about, and all of us do more and more, is how much these cost. An hour. If you think about a project that involves aircraft, ships, ground-based facilities, all of us who are there, our per diem, our salaries, and all this kind of stuff, $50,000 an hour for one of these big projects is not unheard of. We have to be careful, and one of the things we try to do is to help the scientists understand, that there's only so much money we have here, and we want to be careful about using it wisely. So one of the things that we did back in this was 2005, I think, was the RAINX project. And the RAINX project, and thanks to some of the people in the room and some that are not, we developed a display capability called at the time Zebra, which allowed us to look at all manner of instruments here. In this case, there were 4 different aircraft. There were ground-based radars, which was the NEXRAD array. You can see the satellite picture. So we are flying around Hurricane Rita. We left from Tampa, Florida, over here. We came into the storm, and we circled around, flying with the winds, if you will, around the circulating storm, and examined it with the Eldora radar, and also with the NOAA P3 tail Doppler radars, the Eldora tail Doppler radar on the NRL P3, and the NOAA aircraft as well. In addition, the U.S. Air Force was flying in this. This kind of real-time display is something that did not come about until we got the capability, one, to bring the data together, secondly, to reformat the data to a common form, and then finally to have the horsepower to put together displays like this. So you can see the aircraft leaving from Tampa and flying out to the storm. They're skittering back and forth around that storm. So again, this was Rita as it came ashore. I think Wenchow, this was your first soiree into the eye of a storm. Is that right? Flying, huh? Next day. Yeah. All right. In any case, fascinating capabilities that we're able to use now. All right, more lessons learned. Never deploy to the field looking like the prey of the local predators. So a very good friend of ours in the old days, a software engineer, came with me to the Arctic, and we were going out on the Arctic ice for 6 weeks, and we had to dress appropriately, heavy clothes and so forth. And she bought this lovely Lands End or Eddie Bauer, full-length parka and all this. Well, the problem is we were going to the Arctic, so there are polar bears there, and the polar bear's favorite meal is a seal. And seals are typically gray or black, as was her coat. So we had the briefing on the Arctic icebreaker before we went out, and the caution by the local logistics manager was, this coat you have, Leah, you really don't want to go outside without others around because you look like something that would be very good to eat by the by the polar bears. Don't volunteer for a 45-day deployment on a Chinese ship if you don't like rice. And a colleague who's not here right now, that was Scott was the victim of that during Toga Core. And we can't get him to go to a Chinese restaurant. We haven't been able to since, you know. There's a requirement that you must design the project on a paper napkin before you actually can bring it to fruition in a proposal. I have on my desk different from several different projects. The TPAR project, the Toga Core project was done on a napkin. There's actually a picture in Rick Carbone's office about this. This is where this is where the initial thoughts finally come together. When you turn on the water and it fills the bathtub to look like an aquarium, you might want to postpone the bath. So that was what happened to me in the Solomon Islands. And we've gone through this. Sometimes you chase a storm, sometimes the storms chase you. Theory and reality can be so easily confused. And this is a symptom of having lofty expectations, but really not realizing what down-to-earth challenges there are. The best time to start thinking about your retirement is before your boss starts thinking about your retirement. Okay, this is what I did, and it's worked out. It's worked out extremely well. One of the last things I want to talk to you about are the logistics. The logistics of the projects are always an important part of this, and I'll leave you to consider these. The planning part, you can see here, they're just simply spelling out the school zone here in the upper left, right? And then, of course, there's the deployment phase of the project. And as you can see by this picture, you can never have enough chairs. You see this, right? There are chairs everywhere. They're hanging off they're hanging off the thing. And here's the operations center staff, up on top, to see what's going on. And then of course there's the support and not overloading the capabilities of the system to do what you want to do. So this leads into some of the more unique aspects of the field projects. They have personalities of their own, molded by the PIs, and it's something that everybody has to be aware of. And the medications too. What I should have done, there were a couple of projects where I really needed to get a list of medications so I could at least understand the symptoms when they went on. But I'll tell you right now, in Toga Core, we all had to take a malaria medication, and the medication they chose at that time had an interesting side effect related to vivid dreams. And to see everyone working hard out there taking this medication and watching what happened after that was just, oh my, something to behold. Right, the scale of the projects. I've shown you a small sample like out in Colorado, and then we have HIPPO or another one of these that regional and global coverage. We can go to any of these scales. A dry run. So, what has happened in these days to try to, there's good and bad things about a dry run. The good thing is you get to test out your thought process for coming up with the operational strategies and whatnot. The bad news is that sometimes the year of the dry run is far better meteorologically than the year of the operation, and that really is annoying. Am I right, Tammy? So seek out in-country support. When you go to these foreign countries, you need to get somebody on site that can help you through the unique challenges that occur with coming to the various countries. Surprises are a given. On-site operations and remote operations are now all a part of the process, and you have to just plan for those to make sure those things can be done. It doesn't really matter what you plan. Mom Nature will give you the sampling opportunities, and you'll have to respond to those. Safety and security. They're important parts of things. I'll come back to that in just a minute. The project groupie. So project groupie, if you're familiar with the old rock and roll, groupies were the people that showed up at all the concerts, just kind of. Well, on field project, I observed that the same thing happens. They get funding at the last moment, and they come onto the project, and then they try to, how shall I say, invoke their will on the objectives of the project. It's something that the science team has to be careful of, and someone like myself has to be telling the science team about, so we don't get in trouble that way. One of the aspects of the scales, the large scale, this is one that I also was heavily involved with, the T-Park project. And in this project, we tracked a super typhoon Senlaku across the West Pacific here. Let me give you, so the different colors are the aircraft. Again, the NRL P-3 with Eldora, U.S. Air Force C-130, the Dot Star aircraft, which was a aircraft from Taiwan that had a drop sound capability, and also a Falcon 20. These aircraft were all based in different places. This what I'm showing you here is the summary of 13 days or 14 days of operations to track. The storm came out of this region near Guam. It formed up. You can see here we tracked the storm. You can follow that track through here. It's probably hard to see a little bit, and then it came up here. We wanted to study the growth of the storm as well as the extratropical transition of the storm. So through its mature stage. In addition, it came, very close to Taiwan. It came very close to Okinawa. You can see we have aircraft based in Guam. We have them in Taiwan. We had aircraft in Okinawa and also up towards Tokyo, all flying in this storm. We simply could not have done this when I started supporting field projects back in the 1980s. It was not possible to do something like this. This is one of the hallmarks of the support that I've given, and it's one of the remarkable things now that we seem to think can be routine as we prepare for these. And it's something that we know we can do, as long as we have the time and the planning to take care of it. Safety and security, right. So they're more important than ever. We have to make sure that we take care of the people in the field as well as the equipment and facilities that we have. As you all know, in the last 10 years, the whole idea of terror and other things have come into the picture a little bit. It's something that the project managers have to take into account as we're planning when and where to do these projects. The one I don't mention here is in the Dynamo project. Certainly something that wasn't on my bucket list was the overthrow of government that occurred while we were in the field. Right? That's always one that's certainly something you want to plan for. And the good news is everything worked out okay, but there was a fair amount of wringing of hands, shall we say, during that. You got to remain agile and flexible because you just never know. You don't know what's gonna happen here. The identification and control of risk is something that's very, very important. It's part of project management. I'll come back to that in just a minute. So, what does the future hold? Anywhere on the globe, data and information access all the time. The science community demands this. We are put in the position of trying to help make that happen. Fortunately, we have the tools and we have the people that are smart enough to make things like that go on, and that's a very, very important thing as we go forward. New science creates new science questions. We really haven't answered all the questions yet. Some people say, well, we don't need to do this anymore. Yeah, well, we usually do. They're usually something else. Increase international collaboration. I think this is something we have seen in the past. It has waned, and I think it's going to come back in the future, where we want to provide the kinds of support to these international efforts. In addition to that, there's a whole new set of groups that are interested in these projects. The utility companies, local engineering. This is everything from flooding to typhoon or hurricane strength and track. And then, of course, local and regional governments' interest in taking care of their people. New facilities, my word. We've got many new facilities coming to the table, and the doors they will open to us in the next decades will be astounding. I'll watch from afar, but if the last 20 years is an indication of the next 20 years, it's going to be an exciting time to be at the National Center for Atmospheric Research. Project management. So this is something, it's project management's been around since the 2500 BC. You don't build a pyramid without some form of project management. However, now it's taking a more formal structure, and it does require attention to detail, and in many, many cases, implementing a good project management strategy will help you avoid some of the mistakes, if you will, at the beginning, or some of the things that you missed as you're planning for the project in terms of cost and other things. In the Earth Observing Lab, we've implemented a much stronger use of project management. We try to help our science teams, our PI teams, and the projects that we're doing internally by utilizing the various techniques and capabilities that project management affords us. And it's something that we will continue to utilize, and I think utilize more as we move forward. Funding's always going to be a challenge. There's no lack of ideas, but there is a lack of dollars to do it, and competition for whatever money is out there. And we want to, we have to justify. The National Science Foundation says that only between 15 and 20% of the proposals submitted to them they're ever able to fund. If you think about that, you got to be persistent. You got to be patient in order to be in the field we're in. And as I said, very interesting times ahead, I think. And now finally some quotes from the field. So these are in no particular order. There aren't very many of them. I have green books. I have a green book a year for the last 35 years, and I would write down some of the more interesting quotes through all the. We have no way near the time to go through these. So I'll just give you a few that I came upon. The worst day to choose is always the day we choose. So that's Greg McFarquhar from the Socrates project. This should be straightforward, and that's Jim Doyle from the TCI project about flying an aircraft over top of a Cat 5 storm out in the Eastern Pacific to study it. Sue, with all due respect, is there a chemist in the room? No, then we're safe. Okay? It's anonymous because I chose to keep it anonymous. I have the name if I can talk to you after. Data is our dope. So Mohan Ramamurthy, he's the former director of Unidata, and now several other things he does over in UCAR. But he was a colleague and a co-PI of mine on the ACADIS project, which is an Arctic data management system. And this is so true. And it's something that we are very proud of, developing a data management system for the Arctic Systems Science Program and NSF they never had before. We were at the forefront of putting that system together for them. Always keep the greasy side of the aircraft towards the earth. This is very, very good advice. You know what that means. The shiny side's always up on top. You never want to have the aircraft flip over, right? So Wayne Sand, a colleague I knew as a pilot when I worked at the Bureau of Reclamation, and he's been consulting with our aviation program for many years. He was in the RAP program as well. He was my supervisor in the RAP program as we developed the TDWR radar capabilities there. I have two questions, but I can't remember the second one. However, I have an excuse. I'm 100 years old. So Jaak Kutner. Jaak was my mentor here. He helped me understand and understand how to do this, how to help the science teams do this, how to keep all these different balls in the air. He's a sorely missed colleague and very good friend, and but he makes these nuggets, just nuggets. The gentleman would come up with. So finally, what am I going to do next? Well, that's one right there. Those are oysters, if you don't know what those are. This is golf, and if you look carefully, right there, that's an alligator. Now, if you're standing on this, it's a tee shot, so you're trying to hit over out onto that fairway beyond the pond, beyond the little pond there. You've never been under so much pressure as to hit the ball well, because you do not want to hit that alligator. Now, Morris and I played a lot of golf together, and personally, I think he would be in much worse straits with this particular scenario than I was. Next, I do like to body surf and boogie board, and that's something that I do, and then just sit by the beach and just enjoy that. And then from the view that I have now from my new office on the this is in Murrells Inlet in South Carolina, where we have a retirement home. That's all I have. I want to say that many of you in the room, we've worked together. This cannot be done without all of us working together, and we've worked together as teams for so long. We get used to it. We're so fortunate to have the team around us that we have and to be able to work together. And I'll stop there. Thanks.
Thanks, Jim.
Mm-hmm.
Very entertaining talk, or should I say very entertaining opinion you didn't have. Right. So any opinions that you don't have?
This would be the time for the second opinions. If you Okay. Gary.
So you mentioned cost. Did you ever come up with a situation where, we always think, add one little facility because we're already spending so much money. Let's add a few more things because it'll be so much more worthwhile to share these observations. Do you know what the cutoff period is? Like where we keep adding becomes counterproductive? Did you come up with a project where we shouldn't have added something?
What seems to happen so let's see, Gary's question, because he wasn't by the mic, was, do we reach a point where if we keep adding facilities that it's counterproductive? What tends to happen is adding facilities means you add scientists, and when you add scientists, you add opinions. And when you add opinions, what you do is you begin to dilute the primary objectives of the project. So as long as everyone's willing to keep that clear, what the science objectives are and what the priorities are, they can be extremely beneficial to the project. I have seen that situation as well. But figuring out that while not disturbing the primary objectives of the project is the challenge. Morris.
Jim, with the technological improvements with communication and net and all of that, it seems like we're getting quickly to a point where the science PIs could operate from their offices, remote experiments around the world. Do you think of that as a positive or a negative?
Well, you and I in particular have been to the field. We know what the advantage is to being in the field and the interactions and the specifics that go on there. But I do think there are scenarios and science goals that can be very smartly and more importantly, cost effectively achieved doing this kind of remote coordination control from your desk or from your, let's see, our friend Terry Hoke back here is very proud of the fact that he's told me this several times. He can sit in the living room. He can sit in his living room in his Barcalounger and pop songs out of the G5 as fast as anyone would like. I mean, this seems entirely civilized to me,
While you're watching the video.
Yeah.
I like your quotes, especially the one about the chemists. And of all the skills that we needed to pass on to the earlier career folks, keeping track of some of these quotes seems to be worthwhile. I appreciate the personal side of these field projects that you bring out, and just want to point out that I hope we have folks that continue this tradition of keeping track of some of these things that go on that make the human side of science a bit more relevant to the rest of us. It's not just project management; it's people that make this happen. And when you look at these quotes, you're kind of reminded of the people side of it, and that's a tradition that I hope you can pass on to the next generation.
Thanks, Jeff. The thing that one of the things that we have said in a couple of projects is sarcasm. It's the glue that keeps the project together, you know. And I'll be the first to admit that I can be sarcastic at times. But the humor part of this is key. It keeps you civilized, it keeps you civil, and it also keeps you from taking this whole thing too seriously. You need to take time and enjoy what you're doing. The opportunities that we have, no one has these kinds of opportunities. It's remarkable. James.
Well, first I'd like to thank you for all the wonderful help you've given us through these field programs. It's just been unparalleled. It's been great. Second, I was kind of wondering, of all these 80-some field programs, which one's the most memorable to you, and why is that?
Well, let's see. So there are probably a couple that stand out. One for good things and one for bad things. I'll tell you about the good one, not the bad one. The good one is the MAP project. So the mesoscale alpine project, it occurred in Europe, and we had two operations center, one in Innsbruck, Austria, the other in Milano, Italy, and we had to work together to. This is this matter that Gary and I were discussing, where how many different new scientists need to come into the project before it unravels. Well, MAP reached they got very close to that magic tipping point where things just go out of control. There were 18 different, quote, principal science objectives that they were trying to achieve in MAP. 18 of them. And these were in everything from clear skies to big full storm situations, windstorm events, and so forth. And keeping all that straight with the multiplicity of facilities and all that was challenging but fascinating. The other thing is I had to do a lot of planning in 3 different nations to get all the pieces and parts put together for this, and I found that to be very rewarding, personally, to know that you helped them bring this together and we actually, pulled it off, Without bringing up the name of the bad project, I will say that the biggest thing that can be the challenge is the personalities. And if you have to spend all your time keeping renowned, world famous, egocentric scientists away from each other long enough to get the job done, then we're all missing the point, and that does happen occasionally. And so be it.
So this is the advertisement. So Jim will present a shorter version of this talk at the AMS annual meeting Wednesday, right?
Monday. Monday afternoon.
Okay.
In the History Symposium of the AMS. Never been to that one before.
Second, just curious, on all those quotes, when are you going to publish that?
The quotes?
Yes.
Oh, it would never be published. Are you serious? I have taken the books home, so there's no chance of them being, taken out of my office. The thing I didn't bring up, but you remind me, the thing I did not bring up is that I have 2 envelopes in my desk. One envelope contains the names of the scientists that I would dearly love to do this again, to go to the field again. And the other, sadly larger envelope has the scientist that probably I don't need to do business with again if we can possibly avoid it. Now those lists can be purchased.
Yeah, you stole my line. I think many scientists will pay to get your book.
Any other question? Any other thoughts? If not, then please let's give Jim another round of applause. Thank you.
Thanks very much.